So we will resume our conference presentations now. So first of all, I'm Daniel Ritchie. I'm a graduate student here at the DLL at UCI. And so our next panel is on personalized teaching and learning. You'll hear about a lot of really interesting uses of generative AI in education. I'm personally really excited about these talks because I know that very innovative and very new uses. So our first speaker is one of my mentors, actually, Dr. Ying, an assistant professor of learning sciences and technology at the Marsal Family School of Education at the University of Michigan. So take it away, Ying.
Thank you, Daniel. Let me share my screen. Okay, can you see my screen? Okay, so good afternoon, everyone. So I'm very excited to be here to talk about the intersection of generative AI and personalized learning. So there are actually many different ways we could provide personalized learning to support students. And one of the powerful ways is to engage students in particular young children in interactive dialogue. And this is the core of my research. So in today's talk, I'm going to start by giving you a quick snapshot of how we've been using AI in the past few years in our research to support interactive dialogue. From there, we will venture in our newer projects that specifically focus on generative AI. So from learning sciences research, we understand that children, whether they are reading a book, watching a TV show, or playing a game, they learn more effectively when they engage in conversation with a knowledgeable adult. So this conversation typically involves the adult posing a question, listening to the child's response, and then providing feedback or elaborating on the discussion based on the child's input. So with the evolution of technology, we're now at a stage where even young children can converse with AI. So this AI can be programmed to ask educational questions and offer scaffolding to support children's learning, which is precisely what a project Mark Warschauer and I initiated does. So we call it Converse to Learn project. Children learn through conversations. So in this Converse to Learn project, we're integrating AI-driven dialogue into a range of educational media, including television, smart speakers, and ebooks. So now I'm going to share one of our ongoing projects that we started several years ago. In this project, we partnered with PBS Kids to create conversational videos. So these videos allow children to interact with characters from TV shows, including a preschool science program called Eleanor Wonders Why, featuring a bunny named Eleanor. In these conversational videos, Eleanor will be powered by AI to engage with children by asking questions and replying to them. Eleanor's questions usually involve prompting children to explain or make observations about the scenes in the story. So now I'm going to share with you a 30-second video of how a child talks with Eleanor.
We made a really fast car. It's so fun to try different things and figure out what works and what doesn't work to make the car go faster. What did we change to make our car go faster?
To make a pointy thing so I can go more faster.
You are right. The pointy shape on the front made the car streamlined so it goes faster.
So we've done several studies to understand whether and how these conversational videos can be effective learning tools for children. The findings are pretty consistent across all our studies. As you can see in this graph from one of the studies, When children have the opportunity to interact with the AI-driven conversational character, their science learning scores improved compared to children who simply watched a regular non-interactive video. So now, as promising as this approach is for supporting children's learning, there are also particular challenges we face when developing this technology. And this is how it works. Essentially, we're building a dialogue tree that accounts to many different potential conversations a child could have with this AI-driven character. The first step in creating this dialogue tree is selecting an episode or a story that the conversation will revolve around. So once we have a story, a topic essentially, our research team brainstorm potential questions that a character could ask children. For each of these potential questions, form a branch in our dialogue tree. So for example, in an episode where Eleanor is trying to make her boxy toy car go as fast as her friend's sleek car, we thought that Eleanor should ask children a question or two about the differences between the two toy cars. So our next step is to test our questions with kids. We do this for two reasons. First is to ensure that the questions make sense to real kids, and also to gather a variety of responses that children are likely to provide when asked those questions. So next, we group children's potential responses into different categories. So for example, when asking the question about the differences between the two cars, some children may talk about the differences in shape, while others may discuss differences in color. So with these predetermined response categories in mind, we write feedback that Eleanor could offer to children based on their responses. So by now, you may have noticed that the development of AI-assisted dialogue in this particular context heavily depends on prescripting questions, categories, and feedback. So using this prescripting approach has its advantages. It allows us to leverage the expertise of educational professionals who can carefully craft the questions and feedback that align with educational theories. But there are also challenges that we need to consider. First, since all the feedback must be prescripted, the AI cannot provide real-time customized feedback if the responses cannot fit into the category that we anticipated. And second, manually crafting questions and feedback is labor intensive. Just think about that dialogue tree we just talked about. The more specific answers we aim to capture, the more branches we'll have to create. So this makes it difficult to scale up the integration of AI-assisted dialogue in learning resources to reach broader student population. So now with generative AI, we may be able to explore new pathways that could help navigate these challenges. So this brings us to our first experiment with generative AI. Can off-the-shelf language models like OpenAI's GPT-4 engage children in real-time educational dialogue? To investigate this, we leveraged GPT-4 to create an application that can co-create math-focused stories with children. So the goal is to teach children math vocabulary while engaging them in fun storytelling. So you can see that it is similar to our previous project of interactive videos. Children have back and forth dialogue with the AI. So in this storytelling application, the AI initiates the story and asks a question to prompt the child to respond. And then the AI will acknowledge the children's responses with feedback and continues the story based on the child's input. So this cycle repeats to create a complete story. So as you can see in this video, the AI shows a pretty high degree of responsiveness to children's input and does an excellent job incorporating the child's contribution to the unfolding narrative. So how does the process of developing this AI differs from how we approached our previous projects using prescripted dialogue tree? So in our previous interactive video project with Eleanor and her race car, the researchers were responsible for writing the questions and feedback that Eleanor provides to children. However, with the integration of generative AI, the task of content creation shifted to the AI. As researchers, our role in this context becomes prompt engineering. So rather than constructing an entire dialogue tree, we instead write a plain language prompt that tells the AI how to co-create an educational story with a child. So this is the exact prompt we used in the AI that we saw in the video. So I'll read part of it. So we first tell the AI about the content of the game. So it's a co-creation of a story. And then we tell the AI about the theme of the story. It's a quest style story. So the kids and the character needs to go through a lot of obstacles. Since it's a math-focused story, we instructed the AI to use several math terms. And also we told the AI to use accessible language. So it took us many iterations to reach this prompt. So currently we are conducting an experiment to just figure out the quality of the generated text and children's engagement and how that would support their math learning. So far, prompt engineering seems like it would be a very accessible way to create AI-driven interactive media for children. However, finding a prompt that results in an engaging, educational, and age-appropriate story for young children can be very difficult, if not impossible. So it takes many iterations, trial and errors, and even a prompt that achieves the desired result once might not always perform well in later trials. So we sometimes got a story about a complex differentials or stories with very hard to understand vocabulary or sentence structures, despite our prompt explicitly describing the type of stories we wanted. So to some degree, so how generative AI understands and executes the prompt it is given exists in a black box. Generating content directly for children out of a black box can be somewhat risky. It is extremely difficult to precisely predict when a failure might occur and what that would entail. So this brings to our second stream of work with generative AI, which adopts a human-in-the-loop approach. So imagine the AI serving as a content generator. But in this instance, we actively involve human experts to validate and, if necessary, revise the content. By doing so, the AI can expedite the laborious task of content generation while we reintegrate human experts to ensure the quality and accuracy of the generated content. So we have initiated several projects aimed to understand the best practices for assisting non-technical experts, such as teachers, in this validation and modification process. One of this project is built upon PBS Learning Media. It is a platform housing thousands of educational videos for K-12 students and widely used by teachers across the country. Our goal with this project is to create a teacher AI collaborative platform that would allow teachers to employ generative AI to create intelligent tutors that ask student questions and provide feedback as students watch those videos. More importantly, this platform will provide a simple mechanism for teachers to supervise the intelligent tutors as the AI generates sequences of questions and feedback. So the teachers could guide the tutors' interaction with the students, tailoring the dialogue to meet their instructional goals. But there are also a lot of open questions. So we are carrying out studies to understand, so for example, to what degree the teachers hope to have this process automated, and what level of revisions and modifications do the teachers consider necessary? And also, how does everything fit into teachers' existing workflow? Just to wrap up my presentation, so overall, I'm optimistic about the potential of generative AI could bring to education, especially when we embrace generative AI as a collaborative partner. So I also wanted to emphasize that this research field is a collaborative endeavor that involves stakeholders from many different sectors, including teachers, students, parents, media producers, and the broader educational community. So it is their diverse experiences, innovative use of AI, and also the challenges they face that constantly inspire our research. So I just wanted to say that I consider it a tremendous privilege to be part of this collective journey. Thank you.
Awesome. Thank you, Ying. That was an awesome presentation. And even though I've been a part of that project, getting to see where it's going now with the generative AI is super exciting. So next, we'll be hearing from Dora Demszky, an assistant professor in education data science at Stanford University.
Hello, everyone. Thanks for inviting me to this opportunity. Let me share my screen. Also, I'm in Europe, so originally I didn't know that I would be 9 hours later than California, but I'm glad that everything worked out in the end. All right. Now this. Can everyone see my screen? Great, perfect. Hi, everyone. I'll be talking about something relatively similar to Ying's presentation, but slightly different in terms of not like a student-facing application, but a teacher-facing application of personalized learning driven by language models. So as many of my colleagues in the previous sessions have pointed out, ChatGPT or large language models more broadly have really started to transform how we think about many processes in education, including how we do and how we teach writing, how we think about assessment, etc. And all of these different applications have also spurred a lot of sort of somewhat controversial conversations and raised new challenges related to plagiarism, also about just thinking about like how might we transform education more systematically to accommodate these new technologies and their advancements. Some are really in the positive direction, so I'm really overall pretty optimistic about the potential that AI has. However, what I kind of have noticed in these conversations that they have often overlooked a very promising application that's not focused on writing or assessment, but instead it's focused on something really crucial that happens in an educational process, which is the interaction or discourse between the teacher and the students. Can we use AI to facilitate that discourse? That's really been very challenging in previous, more traditional approaches that required human feedback and observation to teachers. And why is this really important? Well, teacher-student discourse is a vehicle for many important things. It's a vehicle or medium for transmitting new knowledge. It can foster or even be detrimental to a culture of curiosity. We know that it can impart mindsets onto students, for example, growth mindset, which we all know has been correlated very strongly with positive student outcomes. And it can also help the teacher foster a community amongst students and help them feel like they belong and that everyone is nurtured in the classroom. However, as I mentioned, current ways of improving that discourse, even though teachers really want and need that type of coaching, are not really scalable and requires expertise, consistency and regularity, just like any kind of profession, we require consistent, frequent coaching so that you can really get better at it. It's also oftentimes not personalized to the teacher and not necessarily driven by their actual teaching expert or like what happens in the classroom. So it's not necessarily driven by data. And it's oftentimes not adaptive to that specific teacher's needs and background. So for example, different teachers might need to improve on different techniques. They also might need, some might prefer more private type of feedback and some might not mind being observed by several people at once. So all of these things can't really be accommodated in the conventional process. AI teacher feedback, on the other hand, has the potential to deliver more scalable feedback to teachers by learning what that expertise might look like through real experts like instructional coaches, and deliver feedback in a consistent and regular and timely manner. It could also be personalized and data-driven and adaptive. And this is the space that I've been working on in the past few years. How could we build tools that can deliver feedback to teachers powered by natural language processing or AI in a way that's consistent and scalable and low cost? One specific application that I focused on is giving feedback to teachers on their uptake of student ideas, which is a strategy that has been correlated positively with several student outcomes, several other aspects of good instruction, like dialogism in instruction, where students partake in the learning process, etc. So we built this tool called Empowering Teachers that would display to teachers the number of times they took up their students' ideas, and also I showed examples from their lesson when they did that, and allowed them to reflect on their instruction by looking through their transcript and typing up ideas for themselves or their peers as to how they might do more uptake or building on student ideas. So this was like not pre-generative AI that existed, but when this was developed, generative AI wasn't robust yet, so we weren't using that yet. We were using large language models for measurement in this case. And it has shown tremendous potential because we found that this type of automated feedback can improve both instruction and student outcomes after just giving feedback to the instructor twice. And this was, we conducted 2 randomized studies in 2 separate online learning platforms. One is Code in Place, which is a large-scale online programming course hosted by Stanford, and another one is Polygens, which is a research mentorship company that pairs high schoolers with research mentors. And through these 2 studies, we found that as a result of getting feedback, teachers take up student ideas 16% more. They ask more questions from students. They also are more satisfied with the experience of teaching. Students talk more, they're more likely to submit assignments, they give higher course ratings, and they also feel more optimistic about their academic future. So these are really just some indicators that there is a positive benefit of this feedback. These were both in online context, so we don't have like standardized test scores or many other outcomes that you might find in a more traditional K-12 environment, but that's exactly what we're currently testing. So this type of feedback, which is, you get your, AI analyzes your transcripts after you teach, is just one way of how educators could use AI to improve. They could also do it prior to teaching. For example, they could engage with an AI in a simulated environment to practice teaching with simulated students and get feedback like they would in an actual classroom context, but more as, as just a first stage pilot before getting into real students. You could practice, for example, your questioning skills, which might be really helpful, or test, very stressful situations, like if a student is, open up something vulnerable, like how do you respond to them? In many contexts, teachers might not engage with students face-to-face, but through text. This is common among tutoring platforms. So there's a lot of opportunity to provide real-time suggestions to the tutor to how they might respond to students in a more growth mindset way, or in a way that incorporates good teaching practices. And the example I showed you before pertains to this last option, which is giving feedback to teachers after they taught their lessons, so that they can reflect and then improve on their practice, just like you use an exercise tracker to track your progress, and then later use that for improvement. However, one thing that we found is that for either of these applications, we can't simply use ChatGPT off the shelf. So I mentioned that previously we used LLMs to measure practices rather than provide suggestions. And there was actually a reason for that. We have experimented with generative AI, but weren't really satisfied. And that's true still. with the current models that we find. Although we do think we do see some very positive improvements, obviously, to previous iterations. So what we did was we tested ChatGPT off the shelf to provide suggestions for teachers, for elementary math teachers, to improve their instruction. So we used the data set of elementary math classroom transcripts and then fed it to ChatGPT and then asked it to provide suggestions for the teacher to help to elicit more students' reasoning in their classroom. And then we told them, included with a definition of mathematical reasoning, etc. And then we recruited 2 expert teachers with decades of experience. One is also an instructional coach, to evaluate the quality of the feedback that was provided by ChatGPT. So we specifically looked at whether it was a novel suggestion, whether it was relevant, useful, faithful to what actually happened. And what we found is, interestingly, 82% of the time, ChatGPT repeats practices that the teacher already does. So it gives redundant advice. But on the flip side, the suggestions that it provides do encourage positive practices. So it's not necessarily bad, it's just not necessarily useful. It's not very good at channeling expert, insightful feedback to teachers. And yes, maybe we could have done really extensive prompt engineering with the same prompt, but that wasn't the point here. The point was to try out how, let's say, a coach might sit down and play with this tool and see what they would get. And also with some of these more pedagogically high level and challenging things, even with prompting, we don't think that we would improve significantly, because I think, as what Ying said, even though you might provide extremely specific suggestions to the model, some things are just not in the training data. So there's not much data in that ChatGPT has seen that includes pedagogical advice given to teachers on their teaching transcripts. That's just not data you find on the internet. So we need to think about how we might tune these models, either with data or in other ways, that to adapt it to these tasks. So I mentioned kind of going back and forth between generative and measurement and generation, just what we have done successfully in fine-tuning these models is fine-tuning them for measurement. So we have several models that are fine-tuned using expert annotated data on different types of strategies, like teachers' uptake of student ideas, their types of questioning, like are they asking questions that try to probe the student's thinking or just getting them to say the right answer? Is the student reasoning, or are they just saying something, that could be guessing? And then some of these other talk moves that I'll jump into in a little bit. For example, one measure that we recently developed revolves around distinguishing and detecting different types of classroom management practices. So we know from the literature that classroom management is very challenging for teachers to learn, and high-level advice doesn't necessarily translate to what happens in the real classroom when teachers are just trying to get what comes to their mind immediately. So it's really important to help them give feedback on things that are really inside the classroom that are that could help them improve that way. So, for example, punitive and restorative practices differ in terms of whether they try to punish students and threaten them, or whether they're trying to invite feedback, whether they're trying to demonstrate empathy with the students. And these practices, we know, have been, not much has been done empirically in the classroom, but at the high level of disciplining actions, which are the extreme of expulsion, etc., suspension, we know that there are vast inequities among students, and that we know that students who are low-income, students who are of color, tend to be disproportionately affected by more punitive disciplining practices. So this is really important to intervene at the earliest point of when there's, when the teacher is, how the teacher behaves inside the classroom, which is sort of the precursor to all of these much more extreme actions. And after building this measure, we found that teachers indeed practice more punitive behavior management with Hispanic and Black students. and that also behavior management increases during the class and the academic year. So these findings show that this measure is not only useful for giving feedback to teachers, but can be also used by researchers to understand, if you have a larger scale data set, to analyze, or even district professionals to understand the patterns that are happening in the district or in that country, to understand what are the best ways to intervene in behavior management. Now moving on to how we might prompt tune, or how we might tune these models for generating suggestions beyond just measuring different practices. That's what we've been experimenting with over the past year or so. So one central theme that we've been focusing on with my colleagues is helping teachers respond to student mistakes in a way that supports growth mindset. So this project is with my colleague David, who is also on this panel. We've been using a data set, the same elementary math data set that I've touched upon before, to understand, to first of all, extract utterances where the teacher is responding in a mindset undermining way to students when they make mistakes. And we prompt tuned the model really extensively. It took us like 4 to 5 months to work with 2 trained teachers to develop prompts. And also these prompts were influenced by, expertise of Carol Dweck and David and many other people who are really the people who understand growth mindset the most. So we've been using a lot of prompt engineering and other things like self-critique to further improve the model generations, and found that given the appropriate prompt tuning, GPT-4 yields responses that decrease students' feeling of shame, increase the feeling of respect, and challenge-seeking behavior. These are the key indicators of students having growth mindset. Then responses by the original teacher, and also the teachers trained in growth mindset. So it conducted a large-scale evaluation, both with students and teachers, to understand all of these different dimensions. And this is what we found. So it's quite promising. And we think that this indicates that if you tune the model, you could actually use it to coach teachers to improve their practices along these dimensions. And finally, another similar project involved also like responding to student mistakes, but this was in a tutoring context. And what we wanted to do, what we identified in this tutoring context, which is very common in tutoring, is that they employed novice tutors who don't necessarily know about any kind of pedagogical practices or what are the best ways to like remediate student mistakes, which is quite challenging, to be honest, even for a professional teacher. So we worked with expert teachers to break down this process of remediation, of first inferring the type of error a student has, then determining the strategy for responding, like providing a hint or a worked example, and then generating a response that demonstrates both care and is also useful to the student. So this process also took a really long time, but then we did end up with prompts that ended up responses generated by the model that were as effective as the expert math teacher's responses. So that's also quite impressive. And finally, I just wanted to highlight something that others have also touched on, is the issue of bias. So how do we, focus on this application in an ethical way? One thing that I mentioned we are doing is involving expert teachers from diverse backgrounds in each of the research processes, not just at the very end. Ensuring that the training data represents the target population is also obviously important. And one thing that we might need to step away from like traditional machine learning is to not try to look for like a perfect ground truth for our model, for evaluating our model, but instead try to model that ambiguity and intersubjectivity, and also try to understand what impact our model has rather than correlating with some ground truth. So this is what we were doing in the growth mindset approach, and others as well. We are trying to evaluate how these generations are perceived by the students and teachers rather than having it compared to a perfect grand truth. And finally, something that people often ask when we talk about AI teacher feedback is, what about privacy? So we think it's super important that teachers have the control over how their data is being used, and also whether, I don't think that this data should be used to surveil teachers in any way. And there should be an oversight of either by the teacher ideally, or also the district, to make sure that this data is protected. And one important thing to note is, because currently we're working with language data only, not audio or video, you can actually de-identify the data pretty easily. So that allows you, even if you're not showing the data to anyone else, it still allows you to just have that extra level of security to make sure that the processed data doesn't include any identifiers. Thank you.
All right, thank you, Dora. I'll jump right into our next speaker. So our next speaker is David Yeager, an associate professor of psychology at the University of Texas at Austin. So take it away, David.
All right, great. Thanks, everybody. Thanks for the wonderful talk so far. So I'm going to talk about mindset supportive language and about whether we can harness LLMs to provide socially and emotionally supportive language in our classrooms. So a little bit of background. So why mindset supportive language? Well, a lot of our research is focused on students' beliefs about their mindsets, whether they think their abilities can grow and change, or whether they think their abilities are fixed, for instance. But what we've learned more recently is that it really matters whether the teacher supports a student's mindset. It's like not enough for a kid to say, yes, I can grow my math brain, and then have a teacher who says, by the way, if you make any mistake, then that's a permanent scar on your record and you'll never be able to get any points back, et cetera, et cetera. And so our research in general has focused more on what teachers say and do to create a culture in a classroom that supports a student's belief. But part of the problem is that it's not obvious what great growth mindset teachers are saying or how they should be coached on changing their language. And so it actually becomes an interesting natural language processing question of how does an adult communicate their intended culture through subtleties in their language. And we think LLMs are interesting for the same reasons that Dora raised, that suppose we could identify mindset supportive language, how in the world would you ever get teachers to know how to speak differently, right? In the old days, the idea would be you'd have personalized coaches who might charge $150 or $1,000 an hour, and it might take hours and hours in order to coach each teacher, which feels unscalable. But if you could have an LLM chat agent who could help you get even 80% of mindset supportive language right, then you might be able to more efficiently allocate those coaches to help teachers. The problem is that LLMs are not by any means necessarily ready to be fully trusted as mindset coaches. And so for the last 2.5 years, we've been pretty obsessed with testing them, even before the public release of a lot of the recent LLMs. And we've been asking two different questions. One is, how effectively do off-the-shelf LLMs generate mindset supportive language? And number two, does prompt tuning with expert human responses improve LLM's effectiveness? And then today I'll talk about two contexts, college applications and teachers' first day speeches. But of course, Dora already talked about one of our use cases. So the college advising. So college advising is interesting because it's a moment of vulnerability in a young person's life where they don't know if they have what it takes, as it were, to do well in college, and they're going to get accepted or rejected based on that. And so there are lots of mindset thoughts, relevant thoughts in a kid's head. But they're also getting lots of advice from adults, and that advice may or may not be good. But it is going to be influential, because kids don't, especially first in their families to go to college, don't know that much about college. So any information they get might have an outsized impact. Interestingly, the state of Texas signs up every college applicant for an AI-powered chatbot called ADVI. It's run by a company called Mainstay, which gives automated advice on, for instance, filling out your FAFSA or how to find an advisor. But students often text things that are not anything like the mundane procedural questions. They text things like this. Oh, so I want to major in so-and-so. I'm so confused on how to take the prerequisites though. Does my advisor make my schedule for me? I feel like the classes will be so hard, and that's why I'm super scared, right? They're asking things like, basically, am I enough for college? And a robot doesn't know the answer to that, of course. So what Advi does currently is it escalates text messages like this to humans who then reply. And so it would be great if we could coach those advisors to write more mindset supportive replies to these students and help hundreds of thousands of students per year navigate the stress of the college application process. And we might need to do that. But the question is, are LLMs any good at answering emotionally charged questions like this? So here's some testing we did with Lambda, Google's internal LLM, and GPT-3 and GPT-4. The actual Advi text just said, I'm scared. LLM said, no, you're not. It's not a good answer. This year is very stressful. LLM said, I think it's pretty relaxing. I don't have to work during the summer, so I can sit at home and play video games. This is a robot saying this. This is not a human, right? There are other things that are grammatically appropriate for it to say that are also in our tests, but very rarely did it provide the kind of emotional support that anyone with a modicum of emotional intelligence would know how to do. How are the humans? Well, you might think that you could just mine the human responses and then train the LLM to copy those. Student wrote, I'm scared. What did the human write in Advi? Hi, why are you scared? Are you nervous about the college process? If there's something going on in your personal life and you're feeling scared, call 911 immediately. If you could like to talk to someone about what's going on, please contact the crisis text line, et cetera, et cetera. So like, sure, that's fine advice, but it's not dealing with the deeper concerns that students have about the existential fear that they're not adequate and prepared for college, right? Or this year's very stressful. It's like, hi, I know it's a stressful year. This time of year is extra hard. Here are some resources. So it's like fire hosing you with advice, and it's not helpful. So we basically can't use machine learning or NLP analyses to identify naturalistic examples because there was basically no variation in saying the mindset supportive thing in this data set. So what you have to do instead is find bright spots. So people who are likely to generate really strong language and then learn from them. So we conducted analyses. We found above residual, extra equity promoting teachers, 20 of them. One of them, we invited them to Austin for a 3-day session. One of them is this amazing teacher named Sergio Estrada. He's like the Michael Jordan of high school physics teaching. At his school, where 2% of students are college ready, 95% pass college physics. And we were like, Sergio, can you answer these as though you're talking to your juniors and seniors? And he says things like this. So a student says, I feel imposter syndrome. He's like, hey, feeling of imposter syndrome is completely normal. There are many people that you probably look up to that have felt the same way and still feel the same way. Would you mind telling me why you feel imposter syndrome? Many times we're our worst critics. Having an outsider provide a different perspective is helpful. I used to have a student that was admitted to a prestigious school, felt like an imposter because he didn't have as many accomplishments as his new peers. I reminded him he came from a very different background than his peers. He'd accomplished lots with the resources available to him. Many of his peers would not have been able to accomplish the same as he did given his circumstances. You belong, you've worked just as hard. Why do you believe you're an imposter? Right? We call what he does the Sergio trifecta. So the first thing he does is he validates what you say. The second is he asks questions where he seeks to understand. And then he provides an argument where you provide hope for change, usually via some collaboration between him and you. The standard college advisors don't do any of those things. They trivialize your emotions, they tell you what to do, and then they de-obligate themselves or they delegate all the responsibility to the struggling young person, right? So what we did is we generated a Sergio robot, and we also had Carol Dweck, who's my collaborator and advisor, and I helped do this as well. And we wrote 8 Sergio Dweck Yeager responses, and then we prompt tuned LLMs, both Lambda and GPT, to create a hybrid Sergio Dweck bot. How did they do? Well, for validating, the human advisors only validated emotions 21% of the time. Sergio and Carol and I did it 100% of the time. Unfine-tuned LLMs did it even less than the human advisors, 14% of the time. But the fine-tuned model, the prompt-tuned model, did it 79% of the time. So you're getting, 80% of what took us weeks to do with the LLM copies. How about seeking to understand? So asking questions. So rare for humans, we did it all the time. LLMs only did it 11%. Prompt tuned, you get 54%. How about making an argument about how the future could be better? There, it's interesting. The humans never did it. We did it all the time. LLMs never did it. But even with prompt tuning, it hardly did it. So it's interesting that you get some superficial features, but not the deeper argumentation feature. So the interim conclusion is that the robot LLM learned the first two parts of the trifecta well, exceeding the performance of average humans and untuned LLMs. This is useful because it took us 2 to 3 weeks to write those 7 text message replies, suggesting LLMs can scale up expertise in some conditions, but they were not good at copying hope for the future. It couldn't generate an argument for why a young person's difficult circumstances now could change or how to collaborate on helping that change. This is an actual limitation with LLMs. And this is very important, that this is not like, we need more data. This is not a data problem. This is like, think about it. The LLMs are trained on the language on the internet. It's what people tend to say, right? It's not guessing what a listener needs to hear to feel different or feel better, right? It's not making a logical inference about the emotional state of the listener. And so it can copy features that are like things you tend to say, but it won't be able to say, for instance, if you tell it that you're stressed about college, it won't say, well, yeah, the reason why you're stressed is because we create so much pressure around college that it's all or nothing. You're either great or you're not, et cetera, right? So a real limitation is using LLMs to generate language, not just that you tend to hear, but that you need to hear, and that might be rare in the training data, and it requires some inferences about how someone else is feeling. Test number 2 is a kind of circumscribed version. It was really, basically, with Dora, wanted to create a coaching tool where teachers could be coached on writing a first day of class speech. But as a first step, we wanted to see how good the LLMs were at generating this language. This is a little bit easier than the naturalistic discourse or than in Dora's talk. What we did is we had a bright spot, Sergio, tell us what he says in his actual physics class around what learning math and physics is like. What happens if you struggle? Should you ask questions? Can you revise and redo your work? What do tests and exams mean? How have previous students done? We have him tell us that information. And then we had a 3-day training with math teachers on Sergio's growth mindset practices developed by me and Carol Dweck, et cetera. So this is time intensive. We're basically creating new exemplars. And the reason why, of course, is that there's not a database of great growth mindset first day of class speeches because it's relatively rare for teachers to say this kind of stuff. So we couldn't just find a large corpus and then machine learning our way to it. And then what we did is we had a new sample of 1,000 teenagers evaluate these speeches. Note that this is what we call impact evaluation. This is different than what I showed you a moment ago. This is like we researchers coded this. We're saying, did it have the elements? What you actually want to know usually is what's the impact on a new kid or a new user. So this is closer to the kind of testing that we think should be done more frequently in the field. So the baseline model, baseline LLM would say things like this. Welcome to algebra. For those of you who are new to the class, algebra is just about solving equations. We'll be using algebraic methods to solve equations. It's challenging, but also fun, etc. The prompt tuned based on the Sergio trained teachers was, welcome to my algebra class. I'm eager to start learning with all of you. For those of you who may be feeling a little intimidated by math, I want to let you know that you're capable of learning this material. It may be difficult at first, but with effort and determination, you'll be able to understand it. By the end of the year, you'll be able to solve problems that once seemed impossible, et cetera, et cetera. So it's pretty good. It's not perfect. And what we find is when the new 1,000 kids evaluate it, the baseline LLM is perceived as about a 4 on a 6 of growth mindset. The prompt tuned is significantly higher, and it's about 80% of the way to the human teachers. So again, it's good, it's better. We're still learning what parts it did and didn't do well, because this is brand new data I've been working on for a while, but certainly promising. So conclusions are really that off-the-shelf LLMs are not good enough yet, but they're widely in use. And this is terrifying to me. I can't tell you the number of times that we very easily got the LLMs to say, for instance, if a kid is struggling, sounds like you should quit what you're doing and do something else. That's the last thing you want an automated tutor to be telling a kid if they're asking questions when they're confused. Conventional pipeline of revising LLMs probably won't work. You can't just scrape available data, identify the good examples, and fine tune on that, because in general, the public is pretty bad at a lot of these things because they're subtle. And even Carol and I had to turn to experts like Sergio, who wasn't fully aware of what he was doing. He was just doing it. So it actually was a long process of figuring out what the right language was. And it's not obvious that you can just scrape it your way to it. The expert language is promising, but prompt engineering is still super important. There's still questions about echoing more complex arguments, like about change. You need to apply it to a narrower set of settings, like first day of class speech or reply to this text message. And it's unclear if you could score kind of any corpus of text for its mindsetiness. Those are open questions. But I do think that there are immediate applications, which is incorporation in Dora-like coaching tools for circumscribed mindset moments. Like, what do you say on the first day, after mistakes, introducing a challenging concept, debriefing a low test score? And I think they're kind of early stage tests where I do think it would be possible to give teachers automated feedback and scale up coaching. So in there, thanks for your attention, and I'm excited to see the next talk.
All right, thanks, David. That was a super interesting presentation. Now we'll hear from Cindy Berger from Duolingo, the technology company that many of us know that teaches you languages in a fun way on your phone. All right, Cindy, it's all you.
Great, thank you. I will assume you can hear me and see me unless I hear otherwise. It is a pleasure to be here today. Those were really interesting talks, and yeah, looking forward to talking more about how we are leveraging generative AI at Duolingo to offer better personalized learning. So first, a quick word about who we are. If you're not familiar, Duolingo is the world's most downloaded education app. We're most known for offering language learning, though we're kind of exploring other spaces as well right now. We have over 500 million learners, and we offer over 100 courses teaching over 40 languages. The reason why those two numbers are different is because our language courses are directional. So we don't just offer English, we offer English for Spanish speakers or English for Chinese speakers, etc. And our mission is to develop the best education in the world and make it universally available. We think the best way to do that is to leverage AI technology. So we are actively using GPT-4 to personalize learning and offer the best education that we can. I'm going to talk about a few ways that we're doing that today, because there's not a lot of time. I'm not doing a deep dive into any of these. I'll just kind of do like a high-level flyover of 4 initiatives right now, and then happy to answer any follow-up questions. But first, we are working hard to offer real-world language practice through a feature we have called Role Play. It's kind of like a chatbot, and I'll show you what that looks like in a minute. We provide dynamically generated feedback to learners a couple different ways. We are offering adaptive lessons to our learners that gradually increase the difficulty to try to really target the zone of proximal development. And we're also generating content with generative AI for something we have called the Duolingo English test. It's an English language proficiency test. Okay, OpenAI approached us in fall of 2022, and we entered into an arrangement with them to be an early adapter release partner with GPT-4, which is the latest iteration of all the stuff that powers ChatGPT. And once we started talking with them, we immediately started playing with GPT-4. And this is one of the first features that arose from having that more robust LLM. And we call it role play. It's very much like a chatbot. Learners have the opportunity to practice the language they're learning in some sort of real world setting. So what you see here is help a lost tourist. You're finishing your espresso in Paris and see a tourist who looks lost. Let's help. And learners will always talk to one of our world characters. We have 9 iconic world characters, and in each scenario, the world character pretends to be some sort of language speaker in the real world. I asked a designer to touch up UI elements, and I'm seeing here that the last message is a bit of a non sequitur, but this is not quite exactly what a learner would see. But the learner begins speaking to our avatar, and then the avatar responds intelligently throughout. We are always targeting a specific learning objective or objectives throughout, and a specific CFR level. We use an external standard for language proficiency. Because this can be challenging, like you can do language exercises all day long in somewhat of a controlled setting, but when you're asked to actually produce the target language for the first time, it's really scary. And we have found that it's even scary if learners are talking to a robot. And so we offer scaffolding in a number of ways, and we're still kind of optimizing our approach to scaffolding. But here you can see on the screen the horizontal scroll bar right above the keyboard. These are dynamically generated options that a learner could use if they want to respond. And the way we do this is we get GPT to predict what the most likely response to a question is, and then we offer a few sentence starters that they could choose from if they want. And then as you scroll to the right, there are additional words and phrases that they could use to kind of build their answer. We don't provide everything that you would need to respond, but enough to where hopefully a learner gets the boost that they need. And of course, the learner can type or speak here, their choice. We also want this to be a very engaging, narrative-driven experience, but this is tough, especially for beginning learners. It's very hard to drive a dialogue or a narrative forward with dialogue alone. So for most of our scenarios, as you can see here, about halfway or 2/3 of the way through, we would offer a plot twist of some sort where like something happens and then the learner has a choice to do one of 2 things. These are actually dynamically generated by GPT as well. We're trying to get better and better at them because we want the plot twist to either derive from some attribute of the character, like Eddie in this case, the goofy blonde guy who's very clumsy, or maybe something that the learner has said in a previous dialogue, so it really doesn't feel like it comes out of thin air. And this just branches, and then the conversation continues. And finally, when the conversation is complete, I don't have a screen for this, but we offer a summary. We praise the learner for having achieved some sort of real world goal, even if it's just asking for directions or ordering food and drink. And then we return to the conversation and provide feedback that the learner can scroll through vertically if they want. So we will correct grammar, and they could click to see what grammar was corrected. And then there's also a dynamically generated explanation so learners know why it was corrected. And that will be a little bit different every time as well. And we're working on other more sophisticated types of feedback. I'm pretty excited about giving feedback on tone, politeness, register, and then some elements of lexical choice as well, or maybe lexical specificity for more advanced learners. Okay, another space where we are leveraging AI is through dynamically generated feedback. So as learners are completing their regular lessons, so we're kind of out of role play now, back into the regular lessons, it might be the case that a learner goes to, say, fill in a blank, and they're not quite sure what to do. They need some help, or they answer incorrectly and they're not sure why, or they answer correctly and they're not sure why. They want to maybe like hypothesis test a little bit. So we have 2 features addressing this need. The first is an on-call tip. So if you look at the bottom left, you see the little, that's our Duolingo mascot, Al. He's waving. And if you needed to, you could tap him here and get help answering. So in this case, the learner is asked to translate "I like rice with chicken" into Spanish. And the verb gustar is a little tricky, and maybe they need help with that. So these are dynamically generated, and GPT is anticipating what part of the exercise is challenging and the learner needs help with. And then once a learner has responded, if they still have some questions, they can move to this screen and then actually choose the part of their response that they want to understand better. So in this case, if the learner chose the third token there, they would see this explanation explaining what a plural possessive adjective is and how it agrees with the noun that it modifies. Again, all of these are dynamically generated because if we were to have, we would need an army of content creators because we have hundreds of thousands of potential exercises, maybe even more than that, across all of our courses. And so in order to offer this, we have to use AI. All right, we also have what we call adaptive lessons, and we had these before GPT-4. So Duolingo has always, the last few years used an internally developed machine learning model called BirdBrain. And it learns both from and about learners in order to meet their needs. And what it does is it continuously studies how much our learners know, as well as the difficulty of certain exercise types. And we know that from data we collect over time, and then kind of combines those to offer personalized practice that matches the exact level a learner is at. And again, that's where we're just trying to challenge them just enough to make sure that they're learning. And so we've used BirdBrain to make our best educated guess about what a learner will, whether a learner will get an exercise right. And then we use that knowledge to set proficiency thresholds. And at a certain point in a lesson, a learner will be told, we explicitly tell them, we're going to increase the difficulty here. We think you can handle it. And then we continually adjust this model to make sure that the performance on these more difficult exercises is where we want it to be. So we think this is smart. It's been working pretty well, but we really want to leverage generative AI here to get even better. So we are actively working on this. I don't have much to show right now, but one of the things we want to do is be able to offer personalized practice with GPT-4 generated content. And the way that we'll do that is, of course, to dynamically generate exercises, but also be able to make predictions for unseen content. Because right now, we know the potential difficulty of an exercise because of all the learners who have encountered that exercise in the past. So if it's an exercise that has never been seen before, we need to be able to accurately estimate its difficulty. And once we can do that, we can offer these auto-generated adaptive lessons. And I think there's a lot of fun possibility here to even personalize further, where a learner could queue up an adaptive lesson that targets, say, certain grammatical structures that they've been struggling with, but also choose what context the language will be in, or certain vocabulary they want to practice, or something that they're interested in as well. So there's a lot of opportunity here. And the last thing we're talking about are Duolingo English test. It is a standardized test of English proficiency. We help learners get into schools or jobs that require a language credential. It's computer adaptive, so the questions vary based on the test taker's performance at the time. So there's a single version of the test. And right now it's accepted by over 4,000 universities. So this is a high stakes test. And as such, we take a slightly different approach with some of the AI. But we're using it in two key ways. We're using generative AI, in two key ways here. So in order to adapt to an examinee's performance in real time, we need lots and lots and lots of test items. And again, if we were to rely on content developers for all of that, the cost would inevitably be passed down to test takers, and we don't want that to happen. So we are auto-generating a lot of these. And then security is also an issue. So you can imagine with an online test, someone could take a screenshot of the test, and that would not be great. But in this case, the test items are always changing, and so that's less of a concern. Because this is a high stakes test, we use a human in the loop process, and we do review and edit all of the AI generated content to make sure that test items are virtually indistinguishable from something written by humans. And this is getting better with time. So we were doing this with GPT-3 a couple of years ago. Now that we're using GPT-4, I don't have that data at my fingertips, but the amount of time that we have to spend reviewing and editing has really decreased because it's such a robust LLM. And just to show you a couple of the item types that we use on the DET that we use auto-generated content for, we have an interactive reading test item where we will auto-generate a passage, and then we ask learners to interact with that passage in some way to answer a question. So here they're being asked, what do some environmentalists and economists believe according to the passage? And then they're asked to click and drag to highlight the answer to the question. And this is our interactive listening item, which is a little newer. This one is a simulated conversation, and I believe it's either with a peer or a professor, maybe both. So there are 2 levels of formality represented, and it approximates an authentic communication experience. There is listening, so you would click the avatar there to hear your interlocutor speak, and then there are a number of questions that you answer, you select the best response, and the conversation continues from there based on your response. Okay, like I said, this is kind of just like a high-level overview of some of the spaces where we're using generative AI. I think there's a lot more we're working on. There's a lot more we can and will do. I hope this gets some creative juices flowing. Happy to be here and happy to answer any questions. Thanks.
All right, well, thank you, Cindy, and thank you everybody for presenting. We'll move into a couple questions. Yeah, let's just jump right into it. So first question for everybody. It seemed like everybody utilized some version of human in the loop as like the best way to use generative AI. Do you guys see that ever changing, and why not?
Is this just a free-for-all?
Yeah.
I would say for Duolingo, it probably depends on the use case. So it's by far the best approach for something like a high-stakes English language test where, there's a lot of consequential validity there. But for something like a conversation partner, like the role-play chatbot, we have a lot of guardrails in place there that are doing a very nice job of moderation. So if a learner has something that's inappropriate or off topic, we redirect, we ask them to repeat, or we might kick them out of the experience entirely. It's not perfect, it's getting better, but we really want to allow a lot of discovery and exploration and agency there. So there's less human in the loop, at least dynamically. We do a lot of iteration on the prompts itself to make sure that there are guardrails in place.
In my experience, some of the most harmful things that it can say to you are things that there are no guardrails for, and no real plan by anybody to develop those guardrails, not by Microsoft, not by OpenAI, not by Google. So the guardrails are really good at things like hate speech, and bullying, but they're not good at things like filtering out terrible advice to people. And no one has even generated the list of possible ways in which AI could give you terrible advice, let alone developed a scoring algorithm, let alone evaluated the LLMs comprehensively on all those. And it's really worrisome that it's fully off the chain with no human in the loop directly interacting with people. I think it's a huge problem. And I think it's a potential legal problem. I think once the right research is done to figure out all the ways in which it could be harmful, that's not the obvious things like hate speech, then I think it'll be possible to go back and score all the language that it's been giving to people and to identify things that were potentially psychologically harmful for children, where no human was even reading it. So I think it's a massive issue, and potentially a liability, and something people should be taking seriously, and I don't see anyone doing it.
Yeah, I just wanted to echo about first the importance of including human in the loop, and also how difficult it is to keep the human in the loop. So there are different ways that we could do it. First, so for us, when we develop this kind of in-house media content, we could have researchers or our research assistants to safeguard the content. But I'm thinking one of actually the more useful cases that how we could leverage, for example, the educators, the practitioners who could actually generate content and then leverage their expertise in kind of safeguarding the content AI generated. So that requires a lot of research to understand what are some of the best strategies to and also interfaces that we could remove the technical barriers that prevent the teachers or educators or parents to review the content or verify the content.
Yes, I want to build on everything that David and Ying especially said about keeping humans in the loop and specifically teachers in the loop. In this case, I see one comment, but not only. So I think when we, for example, want to give advice to the teachers, as David said, teachers could also be getting bad advice from the model. Like maybe it just says, oh, good open-ended question is asking why, but that's not actually necessarily good. Oftentimes, other more specific wordings of an open-ended question generate much more student discussion than a why. If you have been a teacher in a classroom, you know that. So I think there are just so many very nuanced things like that the model has no way of knowing. And even if you fine-tune it, it might not deliver that type of feedback. So one thing that we're actively working on, for example, is bringing in instructional coaches in the loop. So people who are really, really the experts. So maybe in David's case, this would be the sort of social psychologist, or I don't know who counts as the real expert in whatever field. And probably it's a diverse group of people, not just one role. But I think first we have to put, aside the sort of resource efficiency question and work towards finding a solution that's really, really robust, and then think about lean, like making things more lean, because otherwise we just run into the risk of building a house of cards that's going to fall apart.
All right, well, thank you for those very insightful responses. We only have a couple minutes left for this section, but I'd like to leave off on a more positive note. So just in two sentences or less to each of the panelists, as LLMs are improving, what are you most excited about for the potential applications of the improvements? Cindy, can we start with you since you went first last time? We'll go in the same order.
Yeah, I mean, I think personalization is what I'm most excited about, especially within the context of Duolingo, so that a learner could actually say, I want to target this grammar, target this handful of vocabulary I'm having trouble with. By the way, I'm traveling to Paris next week. By the way, I'm also interested in, learning French for business purposes or something, and then we can generate a conversation or a story or some sort of interactive writing experience that meets their needs.
Awesome. Oh, hey, where? I no longer see.
I think David had to leave.
Gotcha. Okay, well, then move on to Ying.
Yeah, I would say, so I'm excited about how generative AI could enhance the media children are already exposed to. So for example, television, how we could make television actually even more educational and interactive. This is a media children spend a lot of time on. Yeah, something similar to that.
Yeah, that's a great question. Well, I guess maybe what I've shown in through my work that while LLMs are very good at certain things, they're not necessarily that good at the things of that require this type of high level expertise that involves like pedagogical knowledge. So I'm really excited about maybe like the potential of collecting new data or fine-tuning the models, figuring out how to best, for example, do this reinforcement learning with human feedback with teacher feedback or coach feedback or student feedback, whoever that is, maybe in Duolingo, it could be like embedded in their app, or I don't know, the model could be improving as users are interacting. So I'm really excited about processes that will come about to enable this, like bringing in this type of expertise to fine tune the models towards tasks that's not very good at right now.
Awesome. Well, once again, thank you to all the panelists. That wraps up our presentation on personalized teaching and learning.